Right, so the next set of questions I'm looking at in exercises, or section 2.3, and I'm looking at numbers 5 to 36 in your textbook. The majority of them are pretty self-explanatory. I mean, it's pretty much substitution. So just as one example, if you look at question number 5, it simply says finding the limit. So we're looking for the limit for x cubed, and the limit is as x approaches 2. That's as simple as substitution, so this answer would simply be 8. So you would have 2 to the third, which is 8. And same thing applies, say you had a question like going down to number 10. Question number 10, you have the limit as x approaches 2, and then they give you negative x cubed plus 1. And again, straight up substitution, so basically negative 2 cubed plus 1. And this answer should give you a negative 7. Alright, so that's, these are fairly easy to deal with. Where it starts to get a little bit tricky is numbers 23 to 36. So I'm going to do those with you because I know that's probably where you probably have the larger issue, or the more issues will ensue. So we'll look at the limit, for example. Let's see, this one says the limit as x approaches pi over 2 for sine x. And so a question such as this, again, you have to go back to some trig background, and again, why I want to focus on a little bit on this question to give you a little bit of a heads up. So, okay, so we'll go ahead and we'll substitute. So we know that the limit as x approaches x approaches pi over 2. So this becomes sine pi over 2. Well, by definition, sine pi over 2 is equal to 1. Again, let's go back to the calculator just to prove it. Okay, so if I take sine and I do second pi divide 2 and enter. Oop. Second graph. No, actually, I don't want to use that. My apologies. I'm just going to go out to the general calculator. So sine second pi divide 2. You did notice in the graph they're all ones. Anyway, but that's what you would want to do. Just simple calculation. You could do this on a scientific, by the way. Anything that I'm, with the exception of just giving you visuals, something like this you can do on a scientific without issue. So that would be, again, straight up substitution. Okay, so let's look at number 24. And by the way, you do recall, let's go back to pi, sine. Let's go back to sine function. Just plain old sine x. I hate graph. You notice the sine x always oscillates between y is positive 1 to negative 1, unless there's a change in the amplitude. So we're not getting into that right now, but you can see that is the limitations of the y's. Other than the domain is all real numbers, but it is limited between y is positive 1 and negative 1. So just FYI. Okay, go back to 24. The limit as x approaches pi. And they're giving you the equation 10x. And again, straight substitution. So this will give us tan pi. And that value should be 0. And let's prove it with the calculator. So we're going to go, let's just go back to the general part of the calculator. So we're going to do tan second pi, and there you go. Alright, so these are really not that bad. I think the more you practice them, the stronger you're going to become. So let's look at 25. And I did show you a couple of tricks based on the theorems in regard to determining the limit without even calculating it. So as one example that I did earlier with you guys, this is not number 25, so let me erase that so it doesn't confuse you. But one of the question was that I showed you was something like, sine 3x over x, well, in this case, we know that the limit will be 3. And if this were sine 3x over 2x, then this limit would be 1.5, hence 3 over 2. So those are little tricks that you just focus on the coefficient. Oh, and also remember, there's a number here that this would impact the value of the equation. So just keep that in mind. Okay, so let's look at 25. Here's 25. The limit as x approaches 1, in this case we're giving you cosine pi x over 3. Okay, so as x approaches 1, obviously this will become 1, right? So this will become cosine pi over 3. Again, throw that into the calculator and you should get it 1/2. So let's check it with the calculator. So cosine second pi, oopsie, second, really? Cosine second pi divide 3. Close the calculator out and boom, 0.5. So yes, 1/2. By the way, you know in these calculators, if you are allowed, that you have the function of math fraction, and you can actually get the fraction equivalent. Alright, number 26. Number 26, you have the limit as x approaches 2, and we're giving you pi x over 2. That would be sine pi x over 2. So this would give you sine pi 2 over 2. And we know this will be 0. Okay, so here we go, back to the calculator. So if I have sine second pi, there's your answer. I hope I need not explain why this becomes 1. So basically sine pi is 0, just know that. If you know that by memory, then this would not be an issue. Right, number 27. You have the limit as x approaches 0, and this time you have the secant 2x. Obviously, if I substitute in 0 in here, this becomes secant 0. And we know secant 0 is equal to 1. Okay, so let's explore why that is. Okay, so let's go back to some basics here. So we have sine, cosine, tan. We know that 1 over sine is cosecant. We know that 1 over cosine is secant. And we know that 1 over tan is cotan. So if I'm looking at secant 0, and we know that this is 1, I want to go back to this example. Let's go here. What is cosine 0? Hint, hint. So if I have 1 over, okay, so let's go back here. So if I have 1 over cosine 0, I really have 1 over 1, which is 1. Hence, hence our answer, that the secant of 0 would also equal 1. Okay, so these two go hand in hand in terms of how they're viewed. Don't remember. Okay, so here's 28. 28 has the limit as x approaches pi. And we have cosine 3x. Okay, so this means that I'm looking at the cosine of 3 pi. And so let's play with this one. If we go to the calculator, we're going to say, okay, then cosine of 3 second pi, let's see, second pi, 3 pi, is -1. again, with the scientific calculator, you can get that value as well. Okay, let's look at one that's a little bit more challenging. Actually, no, I'll keep going the same direction. Here's 29. Okay, so we have the limit as x approaches 5 pi over 6 for sine x. So if I pop this into the calculator, I get sine 5 pi over 6. Again, substitute this in the calculator, you'll end up with 1/2. Eventually, if you're familiar with the trigonometry functions and the trigonometric table, or circle I should say, you should be able to figure that that's also 1/2. Here's number 30. You have the limit as x approaches 5 pi over 3 for cosine x. Then same thing we're going to say, okay, then cosine 5 pi over 3, and again that'll give you 1/2. Scientific calculator, just take cosine, throw that in, and you should have your results. 5 more problems and we're done. So here's 31. I'm about to go mow my lawn, so let me see if I get this done fast because it's about to rain. So limit as x approaches 3, and we have the tan of pi x over 4. So we end up with the tan of 3 pi over 4, and that should be -1. Again, we're using scientific calculator or some form of technology to solve for these quickly. So number 32, the same thing applies. You have the limit of the secant. Okay, so we have the limit as x approaches 7 for the secant, and we have pi x over 6, and this becomes the secant of 7 pi over 6, which is going to give you a funny number. It's going to be -2 to the square root of 3 over 3. Number 33, you have the limit of e to the x as x approaches 0. And we have e to the x cosine 2x as the equation. So we plug in 0, we end up with e to the 0 cosine 2 times 0. And therefore this answer should be 1, believe it or not. Okay, so you can prove it with the calculator. First of all, just go back to some basics. So we know that e to the 0 is 1. And we also know that cosine 0, which we've done before, is also 1. So it's not surprising, is it? Okay, number 34. And these are little tricks, by the way, that you need to memorize for the test, or just keep in mind. Keep it really fresh in your mind for the test. So limit of e to the x as x approaches 0. Right, e to the -x sine pi x. And so again, this becomes e to the 0 sine to the 0, and this answer should be 0. Go back to your calculator functions. If you recall, sine of 0 is 0. Alright, even though the second e to the x, or e to the 0 in this case, is 1, but 1 times 0 gives us the 0 final answer. So yes, this is 1, but this is 0, and therefore 1 times 0 is 0. Okay, number 35. You have the limit as x approaches 1, and so we have e to the -x sine pi x, and oh no, wrong question, my apologies, I'm repeating the question, I'm copying wrong. You think I could copy the right thing, right? Alright, 35. So yes, it is the limit as x approaches 1, but this is actually the natural log of 3x plus e to the x. Alright, so if I substitute in 1, I'll end up simplifying this to natural log of 3 plus, and then e to the 1 is just e. We'll leave it at that. That is your answer. Okay, and the last one, number 36. This is the limit as x approaches 1. And we're looking at the natural log of x over e to the x. So if I substitute in 1, I get 1 over e to the 1, natural log, of course. Okay. And we know that this is the same as natural log e to the negative 1, right? Because when you bring up an exponent, a base and an exponent, the exponent changes signs. And so using the calculator, so we're going to do natural log second e to the x negative 1. Close that twice. Your answer should be negative 1. And that's the answer for this one. Alright, so that's 1 through 36. Those are the ones that would probably give you a little bit of a hardship, so hope that was helpful.